Oh, there it is. Hey y'all, it's Grizzly, and thank you so much for watching our vlog though, even though we just started. But according to my script, we are going to learn about Ian Stewart's book called Nature's Number, Chapter 6, The Broken Symmetry. But before we explain what broken symmetry is, let's discuss first what is symmetry. Transition! Hey y'all, it's still Grizzly. So, what is symmetry? Symmetry is defined as a balance and proportionate similarity that is found in two halves of an object. It means one half is the mirror image of the other half. The imaginary line or axis along which you can fold a figure to obtain the symmetrical halves is called the line of symmetry. Also, symmetry can be defined for both regular and irregular shape, since only opposite sides are equal and all sides are equal sometimes. For example, a square is irregular and a rectangle is irregular shape. The images can be divided into identical halves are called symmetrical. The images that cannot be divided into identical halves are called asymmetrical. So, transition again. Hey y'all, it's so Grizzly. I promise this will be the last. In addition for symmetry, our nature also seems to be attracted to symmetry. For many of the most striking patterns in the natural world are symmetric. Some examples are volcanoes with their shape in conical, stars are spherical such as sun, and galaxies are spiral and elliptical. So, let's move on to Shiela. Bye guys!
Hello everyone, it's me Shiela, and right now we will be talking about different kinds of symmetry. The most important ones are reflections, rotations, and translations, or less formally known as flips, turns, and slides. Reflection is a mirror image of the shape. An image will reflect through a line known as the line of reflection. An example is, if you take an object on the plane, pick it up, and flip it over onto its back, you get the same effect as if you had reflected it in a suitable mirror. To find where the mirror should go, choose some point on the original object and look at where the point ends up when the object is flipped. The mirror must go halfway between the point and its image, at right angles to the line that joins them. Reflection can also be carried out in three-dimensional space, but now the mirror is more familiar kind, namely a flat surface. Now, let's go to the second one, rotation. To rotate an object in the plane, you choose a point called the center and turn that object about that center as a wheel turns about its hub. The number of degrees through which you turn the object determines the size of the rotation. When coming to the three-dimensional shapes, we can turn or rotate the objects about an infinite number of imaginary lines, known as rotational axes. An example is that imagine a flower with 4 identical, equally spaced petals. If you rotate the flower 90 degrees, it looks exactly the same. So the transformation, rotate through a right angle, is a symmetry of the flower. And of course, lastly is translation. It is a transformation that slides objects along without rotating them. It is the displacement of a figure or a shape from one place to another, in which means a figure can be moved upward, downward, left, right, or anywhere in the coordinate system. It involves alteration in the position of the object, and hence, there are no changes to the size of the object. The beast honeycombed with its hexagonal tails is an excellent natural occurring example of translation.
Now that we finished discussing the symmetry, the most important kind of symmetry, now let's move on to broken symmetry. What is broken symmetry? It is stated on page 77 that ripples on a pond are examples of broken symmetry. Just imagine a steel pond, so flat that it can be thought as a mathematical plane. You can translate the plane through any distance in any direction, rotate it to any angle above any center, reflect it in any mirror line, and it still looks exactly the same. But when you toss a pebble into the pond, you see patterns. As the pebble hits the flat surface of the pond, it becomes disrupted, therefore loses its symmetry except for the part in which the pebble strikes. Altering the original state of the pond created a new pattern, which is the concentric circles, commonly known as ripples in the water.
A Russian chemist named Boris Molosov discovered a chemical reaction that formed patterns simultaneously. This discovery was modified by another Russian chemist named Anatol Sabotinsky, where he made sure that patterns could form in space as well. So in their honor, any chemical reaction that is similar will have a generic name as Belousov-Sabotinsky, or commonly known as the Daisy reaction. In the Daisy reaction, symmetry breaks spontaneously on its own accord without the help of external stimulus. In contrast, Ian Stewart stated that the term spontaneous does not indicate that there was no cause, but it implies that the cause could be as tiny or as insignificant as you please.
Therefore, we conclude that symmetry breaking, or broken symmetry, is a more dynamic idea, describing changes in pattern. Just like the greatest physicist Pierre Curie stated that effects are as symmetric as their causes. However, Stewart contradicted, stating that the world is full of effects that are not as symmetric as their causes, and this phenomenon is known as spontaneous symmetry breaking. Generally, the breaking of a certain symmetry does not imply that no symmetry is present, but rather the situation where this symmetry is broken is characterized by a lower symmetry than the original one. That is all you need about symmetry breaking. I hope you learned something, and thanks for watching.